I just now have got one, say the debating point that the questions into these books are not so good, but you know, I have given a question right now, but somehow the person who was debating couldn't solve the question. So the book VK Mehta is having good, amazing, say examples to solve, and there are many examples coming in GPU as well. So I request all of you watching this video. VK Mehta is a good book. Nagaraj Kothari is really an amazing book, but the thing is that as an electrical engineer, power system engineer, you should always have that book, that is Nagaraj Kothari, but it has good sums for the practice. Okay, so the question goes this way: a three-phase 50 Hz overhead transmission line, 100 km long, has the following constants: resistance per kilometer per phase is given by 0.1 ohms, inductive reactance per kilometer per phase is given by 0.2 ohms, and capacitive susceptance per kilometer per phase is given by 0.04 to 10 power minus 4 Simon. No. Determine the sending end current, sending end voltage, sending end power factor, and the transmission efficiency when supplying a balanced load of 1000 kilowatt at 66 kV, power factor 0.8 lagging, use nominal T method. Use nominal T method. The same person is writing something. It's done. That's great. So guys, we have got I mean, we are having a medium transmission line right now. Okay, so medium transmission lines like this, it's very important for us to understand how exactly transmission line will look like. So let's make that transmission line that we people have already understood, that it has R by 2, X by 2, then there is a capacitance, then there is L by 2, R by 2, then this is where we are having the three-phase balanced load where transmission line is delivering 10,000 kilowatt or say 10 megawatt at 66 kV with pointed power factor lag. Is it clear? Any doubt on this? So we understood everything. Okay, the values of R and L is also given to me. The R per kilometer per phase is given by 0.1 ohms. We are having 100 kilometer long line, so we can say that the total impedance, I mean total resistance is given by 0.1 multiplied by 100. Is it clear? So per phase, the resistance that we have got multiplied by 100, which is equal to 10 ohms. Is it right? 10 ohms? Fine. Okay. So we can say that from here till here we have 10 ohms, and I have told you that when you go for medium transmission line, the resistance, that impedance is divided by 2. Yes or no? Fine. So we can say that this is R by 2, so that's 5 ohms. This is also 5 ohms. Is it clear? And that's the real part. That's the real part. Okay. Now let me talk about X kilometer per phase. See, once you know this well, you can solve that question so well. I'm teaching you how to start analyzing the question, right? We are just looking at question right now. So we have got X kilometer per kilometer per phase, that is this multiplied by 100, we have got 20 ohms. So this is J10 and this is J10. This is for you to understand. Clear, because it is reactance. Then after you have the value of Y per kilometer per phase. So multiplied by 100, that's 10 power minus 2. So it's multiplied by 100. So it's 0.04 into 10 power minus 2 ohms per phase. This is per phase. This is per phase. This is per phase. Kilometer you multiply. Kilometer you multiply. So much pad raha hai, so much pad raha hai. Clear? So we understood this. Clear. Now, capacitor susceptance, that is the value of Y. So total Y is equal to 0.04 into 10 power minus 2. Done? Any doubt on this? I'm not writing this, it is going to unnecessarily take a huge amount of space over there. Now we have to find out sending end voltage, sending end current, sending end power factor, efficiency when this entire system is delivering 10 megawatt at 66 kV, 0.8 lag power factor. We have to use T, nominal T. So I guess now we know what to do. We should know the vector diagram at first. So we can say that this is my VT. You have to solve the example. You have to solve the example. I'm going to tell you each and everything that you're supposed to do into this example. Fine. The only difficult part in this type of example is calculation. right? That we people have seen in previous examples. So calculation is very laborious, otherwise the concept is very small, right? It's a very tiny little concept. I'm going to give you the concept right now. So I can say that this is my terminal voltage VT. Clear? This is my terminal voltage VT. I take terminal voltage like this, and with respect to which I calculate all the other angles. So I have a 0.8 power factor length, so I can get the exact angle. And as I have been given the values of voltage, power factor, and the power that that particular transmission line is delivering, so we can easily calculate the value of current as well. बगा सा खा के, ठीक है? पता चल रहा है कि नहीं पता चल रहा है? You can calculate the value of current, right? Load current, that is receiving end current. Is it clear? So we will get the value of receiving end current. So the very first thing that you have to do over here in the solution is you have to find out the value of receiving end current. किस formula को use करोगे? P is equal to root 3 VAIL cos phi. Right? So we can say that मेरा नहीं बचा ना मोबाइल. Okay, चलो बेटा आपको पहले हिलाना नहीं है, नहीं तो ये हिल जाएगा, ठीक है? या संभाल के. So we have got IR. We have to calculate the value of IR. Clear हो रहा है नहीं हो रहा है? Okay. कैसे calculate करेंगे? P divided by root 3 VL into cos phi. The value of root 3 is known to me, P is known to me, VL is known to me, 66 kV, and cos phi is also given to me. So all the values are given to me. Is it clear? Fine. So I can easily calculate the value of IR. So I know the value of IR. I also know what is the magnitude. I also know what is the angle. Is it clear? How have I calculated the angle? So angle is given by 0.8 power factor. So cosine phi receiving end is equal to cos inverse of 0.8. समझ पड़ा कि नहीं समझ पड़ा? समझ पड़ा कि नहीं समझ पड़ा? Done? Okay. समझ पड़ रहा है ये? Okay, okay, fine. चल. तो अब ये होने के बाद तो पहला टास्क मेरा आया हो गया. मैं आया और थोड़ा नीचे ड्रॉ करता हूँ. I know that I have to add the capacitor current into it, right? Right? Okay. So I have got the value of IR. Now, moment I have got the value of IR, which is the current flowing over here, the drop will occur like this, and this value is nothing but VR. So I'll add VR plus IR plus I into X, J into IX is going to give me this voltage V, right? So see, now I have all the values. I know VR, I know I know Z, I know Z, right? Okay, and we can definitely calculate V. So we can say that the first part that you've done is about the IR. The second part that you'll do is nothing but your V. That is equal to VR is known to me. Better. Everything that you are taking, you have to take the magnitude of it to take the angle of it. Phasor method. I don't understand, but for you it is phasor method. Okay. So what we can say V, and the value of V that you will get over here will definitely have its own angle and its magnitude. So both the things you can get out of it. Clear हो रहा है कि नहीं हो रहा है? हाँ? आज थोड़ा इंग्लिश में ज़रा पढ़ो जो है angles. I don't know why. I'm sorry. No, there are no new students. They have already attended my lectures in physics here. Still. Anyways, I don't know why I'm talking English right now. एक तो आवड़ता है मुझे बोलूँ तो एक पढ़ दूँ. चल anyways. अनु कमेंट में इंग्लिश पढ़े थे पहला ने तो मुझे 36 में जाकर रहे हैं मुझे whatever it is. So anyways, we got the value of IR, fine, and we are going to put it over here. R plus I into Z. I hope you understood what is the meaning of vector. I'm talking about magnitude and angle, both the things, right? Phasor. Phasor, yeah. Phasor is what, beta? What is phasor?
What is the magnitude?
It is called as phasor. I don't know. It is not called as phasor. Magnitude and angle is nothing.
Phasor diagram.
What is phasor diagram? But what is phasor? What is the basic understanding of phasor? Sir, phasor method. But what is phasor?
I don't know. You told in last previous video that phasor by phasor method we can solve it. That's why.
You don't know. You are in third year. You don't know what is phasor.
I know phasor diagram.
What is phasor?
Vector.
But so vector and phasor both are same, is it?
No.
Then how they are different?
I don't know about phasor. I just know about vector.
Phasor. Anybody else who knows that? What is the phasor? What is a phasor?
A diagram which shows the representation of quantity at particular instant.
phasor is a vector only, but it's half information. Phasor is a rotating vector. Phasor is a rotating vector. उसको phasor बोलते हैं. ठीक है? चल. So VR का वैल्यू पता, I का वैल्यू पता, मैग्नीट्यूड एंगल पता, Z का वैल्यू पता, मैग्नीट्यूड एंगल सब हो जाएगा उससे. पता चला ना? 5 plus G10 करके तेरे को मैग्नीट्यूड एंगल दोनों मिल जाएगा उसका. Cool. So you know the value of V. The moment bloody hell you know the value of V. What you have to calculate? Current flowing through this, which is IC. Which is IC. Now IC you have to calculate. तो IC अभी मैंने क्या किया? IX ये किया और मेरे को मिला D. समझ पड़ा कि नहीं समझ पड़ा? मेरे को ये पता चला कि नहीं पता चला? ये पता चला? ये पता चला? अब IC जो होगा वो exactly उसको perpendicular होगा. Exactly उसको perpendicular होगा. Exactly उसको perpendicular होगा. समझ पड़ा कि नहीं समझ पड़ा? तुझे तो ये this is my second thing to do. This is my second thing to do. क्लियर हुआ कि नहीं हुआ ये करने का? इससे मेरे को V मिलेगा. V में क्या क्या मिलेगा? मैग्नीट्यूड मिलेगा, एंगल मिलेगा. फाइन. पता चला? कैपेसिटर मींस
एक और बड़ी डायमंड को स्ट्रेट 90 डिग्री लागती है.
it should be like this. बराबर? आओ. अब ये डोबा it will be at 90 degree to the voltage by which it is, from which it is taking the current. So what is the voltage across capacitor? It is V. Where is V? This is V. It will be perpendicular to it. So थोड़ा बाकू लागे जो डॉट डाई पाछे माने क्या है? Got it, beta? Got it. See, this is a common problem that every person is facing. Guys, this line if it is not given straight, if it is straight in your books, it is a wrong understanding. The thing is that this angle is always tiny little small angle we have, fine, but it will be having some angle in between VT and V. And the current which is flowing through capacitor, that is IC current, it is always at 90 degree to the voltage from which it is taking current. So the voltage across capacitor is V, so the current which will obviously be perpendicular to it, and it will be perpendicular to the V. So this becomes my IC current which is paid out, okay? And this is IC that I have got. So addition of IC, IR and IC is going to give me the value of IS. समझ पड़ा कि नहीं समझ पड़ा? देखो थियरी पे ही जा रहे हैं, पूरा थियरी पे जा रहे हैं. समझ पड़ रहा है कि नहीं समझ पड़ रहा है? Clear? The best part of this is you just have to put the values. It's easier. You just have to put the values. You should be good with your concept. You should be good with your concept. Concept से ही जा रहा है ना, देखा ना? कितना सिंपल है यार, मेरे को भी आता है, चल. तो यहाँ पे we have got this, कि यहाँ मुझे मैग्नीट्यूड भी मिलेगा, एंगल भी मिलेगा, बराबर है? फाइन. अब मुझे थर्ड केस में क्या करना है? What am I supposed to do in the third case? What am I supposed to do in the third case? Fine. So third case में मेरे को IC ढूंढने का, which is equal to V into Y. Y का एंगल कितना होगा? 90 डिग्री होगा. Y का एंगल कितना होगा? 90 डिग्री. XC का एंगल कितना होता है? -90. माइनस JXC बोलते हैं. पता चला? So it is basically not V into Y. It is the way यहाँ पे I have written J10, no, I have to write JY. Clear हुआ? तो automatically एंगल अरे
Y का J ओमेगा C हो
I'm sorry, J omega C. So susceptance दिया हुआ है ना? क्या ये capacitive susceptance? तो B. I'm so sorry. This is capacitive susceptance. मतलब the value of B is given to G plus JB. G plus G is conductance. Y is admittance. And what is given to me? Capacitive susceptance. Susceptance is B. पता चला कि नहीं पता चला?
Susceptance means positive.
And if it is plus, this will be minus. And if it is minus, it will be plus. So if it is plus, means you are talking about inductor. You are talking about inductor, then only it is plus. So for inductive susceptance, it is minus JB. And for capacitive, Z is R minus JX. Fine. So it is G plus JB. So here I have capacitive susceptance, capacitive susceptance. So it has to be plus JB. Here we are. Fine. Okay. So now I have got the value of JB. तो मैं क्या करेगा? V V into JB। तो अभी V का मैग्नीट्यूड एंगल डाल, J का मीनिंग क्या होता है 90 डिग्री, तो V का वैल्यू जितना है उतना एट एन एंगल 90 डिग्री। समझ पड़ा कि नहीं समझ पड़ा? यहाँ पे गड़बड़ करते हैं, V का वैल्यू जितना है एट एन एंगल 90 डिग्री, वो लिखना भूलने का नहीं है। समझ पड़ा कि नहीं समझ पड़ा? अलग क्लियर हो रहा है? क्लियर हो रहा है? समझ पड़ रहा है कि ओके? नहीं तो ना बोलो, पढ़ रहा है ना? V into B करके करंट मिलता है, हाँ। And once I have got the value of current, the fourth thing that I have is IS, because it is equal to IC plus IR. समझ पड़ा? तो मेरे को IS मिल गया। Once I have got the value of IS, what am I supposed to do? Fifth thing I'll find out VS. So VS is equal to V plus IS into Z by 2. I should write Z by 2. Because formula में तो Z by 2 है ना, मुझे पता है ना वो सही लिखना है ये वाला। समझ पड़ा? तो ये मेरा Z by 2 ही है। क्लियर हो रहा है कि नहीं हो रहा है? ये आपका Z by 2, ये आपका Z by 2 डन। ये समझ पड़ा कि नहीं समझ पड़ा? So we got this thing. IS का वैल्यू पता है, मैग्नीट्यूड एंगल, इसका मैग्नीट्यूड एंगल पता है, ये मैग्नीट्यूड एंगल पता है, सब पता है मेरे को। तो VS मिल गया। अभी मेरे को एफिशिएंसी की बात करने का हो गया ना, सब हो गया। IS मिल गया, VS मिल गया, IS और cos phi को कौन मिल गया? अरे the moment you find out VS, what will happen? You will be able to find out। तो चलो यहाँ पर मैं करता है, यहाँ पे ये मेरा IS हो गया, this becomes my IS, this becomes my IS। समझ पड़ा? तो देखो IS into R और IS into x by 2, so this becomes my VS। समझ पड़ा? तो मुझे VS का जो भी एंगल मिलेगा विद रिस्पेक्ट टू दिस मिलेगा, डन। मुझे IS का ऑलरेडी एंगल पता है विद रिस्पेक्ट टू दिस, तो दिस एंगल प्लस दिस एंगल विल गिव मी द सेंडिंग एंड पावर फैक्टर। समझ पड़ा कि नहीं समझ पड़ा? So here I will be able to get the angle of IS, here I will be able to get the angle of VS, which is obviously with respect to VT। समझ पड़ा कि नहीं समझ पड़ा? So I can easily calculate the angle of IS and VS। अगर आपको पावर एंगल पूछा होगा तो क्या लिखने का?
VT and VS।
Yes, the angle between VT and VS, that is called as power angle delta। तो अभी यहाँ पे जो एंगल मिलेगा that is my power angle basically। समझ पड़ा कि नहीं समझ पड़ा? Fine। Stability analysis में I'll be explaining you all this criteria of delta। Power transfer के लिए it's a very important part। But अभी के लिए आपको power angle पता चल गया, आपको sending and power factor पता चल गया। Okay। बाद में ट्रांसमिशन लाइन की एफिशिएंसी की बात करेंगे। एफिशिएंसी इज इक्वल टू आउटपुट 1 इनटू आउटपुट मेरे को पता है, सो आउटपुट डिवाइड बाय आउटपुट प्लस लॉसेस। तो लॉसेस में कितना हुआ? 3 टाइम्स I sending end square R by 2 plus 3 times I receiving end square R by 2। समझ पड़ा कि नहीं समझ पड़ा? These are the amount of losses which are happening। यहाँ पे करंट अलग है, यहाँ पे करंट अलग है, तो लॉसेस अलग होंगे। समझ पड़ा कि नहीं समझ पड़ा? तो इतना मेरा टोटल पर फेज लॉस हुआ। समझ पड़ा? तो यहाँ पे सारा वो क्वांटिटी अपना होना चाहिए, डन। अरे सॉरी, पूरा सिस्टम का 3 है ना, सो सॉरी।
सर આપણે VS ને IS નો વર્ષે આપણે VS જે છે ફેઝ વોલ્ટેજ પર છે હા
yes we will convert it into line
આપણે એક્ઝામ્પલ લખ્યું છે કે ફેઝ કે લાઈન
always
line voltage
the method that you have is for phase only, that I have explained why it is phase, because you're talking about one conductor and one conductor is phase, right? And finally you have to show what will be the line voltage, sending and line voltage। clear? done? हो जाएगा ना? चलो स्टार्ट सॉल्विंग।